Okay, we're going to look at comparing experimental and theoretical probability with a two-sided coin. So, to start off, I'm going to briefly talk about the theoretical probability, and then we'll run an experiment and see if they're different, if they're the same. At least the coins we're going to use are circular, and because it's two-sided, there's essentially what we usually refer to as a heads and a tails side. So, assuming the coin is evenly weighted. In other words, you have the same chance of landing on one side or the other if you're flipping it or spinning it around. That would mean that half the time, one out of two, so let's say we flip a coin twice, one out of two times, the theoretical probability of getting heads is a half, and the theoretical probability of getting tails would be a half. Okay, how do we find probability? Let's start off. So probability in theory is the, let's say, is number of sides of something would be on the bottom. Number of sides would be your bottom, or possible outcomes, and the number of successful there's only one outcomes would be number of sides or possible outcomes. Okay. A lot of words essentially to figure this out, but a success would be a heads, and if it's going to do one side heads, then one side tails, tails, because it's evenly weighted, you get one of those, and the number of sides or possible outcomes, well, there's only two in a coin. So your theoretical probability is even, for the most part, anytime something's evenly weighted. Experimental probability doesn't always work out the same. And sometimes it does, but it can, you'll see, be a little off. I'm going to give us our percentages here, which would probably intuitively make sense to you. You have a 50% chance of getting head or tail. So considered a fair coin. We're going to jump over here to random.org. I'm going to flip a coin 10 times, and I'm going to do the Canadian loonie. Okay, it's a nice coin. And I'm going to flip it 10 times, and we're going to do a little tally of what we get. So let's take a look at what we've got here. Looks like I'm going to tally we possible tails or a possible heads. Well, tails, I got 1, 2, 3, 4 tails. 1, 2, 3, 4. Wonderful. Heads, we got 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. So 6 heads. And you know what? I'll put H's for the heads just in case we are unsure what is what. The Canadian coin, it literally is a person's head. Tails is usually an animal. There we go, we got it. I'm going to take a picture of this because it'll be somewhat helpful for our note. Okay, here's our tally of how we did. Shows up, perfect. Okay, let's make a little bar chart and then compare our probabilities. So, our bar chart here, we had the possibility, make that a little bit bigger. Our options were either getting heads or tails. Actually, I'm going to go up by 2s because we got a little bit first. So 2, 4, 6, 8, 10. Well, we got, I forgot already, tails we had 4 and heads we had 6. Perfect. So we had 6 heads, here's our bar, and 4 tails. Experimental probability is number of successful trials over total number of trials. So probability of the experiment would be number of successful trials over number of trials. Okay, so in this case, if you recall, I said I was going to flip the coin 10 times. So the probability of getting a head would be over 10. And number of successful trials, well, we got 6 heads. So probability of heads in this experiment was 6 out of 10. And the probability of tails was 4 out of 10. Here, that means this is a 60% likelihood, and this would have been a 40% likelihood. So when we look at the comparison of the two, theoretical probability should get 50%, so half should have been heads, half should have been tails. In our case, we got a little over half were heads and a little less than half were tails. The more trials you run, the closer and closer your experiments should get to the theoretical probability. This is also known as the law of large numbers, okay?